What's up, A2 Trig people? In this lesson, we are going to discuss arithmetic series, not sequence, series. So we've already talked about arithmetic sequences, right? A list of numbers in which you're adding or subtracting the same common difference each time. An arithmetic series is now when you're going to take all of those terms of the sequence and you're going to add them together. So what does that sequence of numbers add up to? A finite series means that it has a first term and a last term, so it has a finite number of terms. An infinite series has infinitely many numbers in it, so it goes on forever and ever and ever and ever and ever and ever and ever. This is going to become a huge, huge concept when you guys venture into Calc 2 down the road. So buckle up and get excited. Now, just like previous lessons, we're going to have a formula for today. So it is very algorithmic, very kind of step-by-step process that you guys will be following. Pretty heavily calculator-based too, which some of you guys might like. So let's get into it. So the sum of a finite arithmetic sequence. I guess we could call this a series, couldn't we? The sum of the first however many terms is going to be the number of terms divided by 2. They're chopping the number of terms in half times the first term in your list plus the last term in your list. So the first term is a sub 1, the last term is a sub n, and however many terms that is represents n. So if I wanted the sum of of 12 terms, that would be 12 divided by 2. What's the first term? What's the 12th term? Boom, go. Now, a little note down here. Your sequence, your list of numbers might not actually start off with a sub 1. So whatever the first term is in the sequence, that's what you're going to just call a sub 1. So you're going to pretend that the sequence starts off at that value. And we'll see an example or two of that later on. Now, some people ask, but Mr. D, why? Why is the formula this way? Well, let's explain it to you here. I've got two examples, and I'll just kind of give you the why this works. There are two things that we have going on, right? We're adding up the first and the last term, and then we're chopping some things in half. So if I were to add the first and the last term, I get 11, right? 1 plus 10, that's 11. And then as I kind of work my way in, 2 and 9, boom, that's 11. 1 and, or not 1, 3 and 8, 7 and 4. All of these pairs of numbers are adding up to 11, right? And I have kind of like a clean half and half. So 1, 2, 3, 4, 5. There were 5 different pairs of 11s that I got when I was doing that summation process. Well, hey, 5 is half of 10, isn't it? And then 1 and 10 combined, that makes 11. So that's kind of where the formula comes from. It works the same way if you have an odd number of terms. So in this case, instead of 10 numbers, now I've only got 9. So 1 plus 9 would be 10. All right. So 1 plus 9 is 10. 2 and 8 is 10. 3 and 7 is 10. 6 and 4 is 10. And then I'm stuck with that lone 5, right? And 5 is half of what? You guessed it, 10. So that's where this formula comes from. Let's see some examples, yeah? All right, what is the sum of even integers, evens, from 2 to 100? So 2, 4, 6, 8, blah, 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 blah. Off to the side here, I've got our summation formula, and then I also have the formula for arithmetic sequences. We might need this, we might not. I just have it there for reference, and that'll be on every single page where we have problems coming up, just as a heads up. All right, so here's what I need to know. How many terms are there? I know the first term is 2, and I know the last term is 100. So how many numbers are there if I'm only counting the evens, right? I'm not counting every number, I'm only counting the evens. Well, that's half as many because the other half are odds. So there would be 50 terms in this sequence. All right, so 50 over 2 times the quantity, 2 plus 100. Remember, 50 is the number of terms, chopped in half. First term is 2, last term is 100. When we do that, we would get 2,550. Not too shabby, right? Don't worry. Some of you probably want to see more challenging problems. I hear you. You like a challenge. Here we go. What if, that's not the problem I want, that's the problem I want. I wanted the sum of numbers that is 4, 9, 14, 19, 24, blah, 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 and then ends at 99. What if I wanted to add all these together? Well, here's what I do know. I know my first term is 4. Cool. And I know my last term is 99. Excellent. What I don't know is how many terms are there? So we're going to have to do some mathing. All right. So when we do this, we are actually going to be employing some previously learned stuff. We're going to be learning or using this formula here because I want to know what term is this? Is this the 15th term? Is this the 38th term? I don't know. What I do know is the first term is 4, the difference is 5. So if I use that formula over here, I would get 5n minus 1 would be the formula to describe this sequence. Okay, and then if I know that 99 is my nth term, what is the n value? Well, that'd be 20. Okay, so then this would be the 20th term. So that means I just found my n value, right? I'm finding the sum of those 20 terms. So 20 over 2 times 4 plus 99. Math it out, you get 1,030. All right, next up, I want the first 150 terms in the given sequence. Well, hey, they just did me a kindness, right? They just told me how many terms there are, so I know my n value. I also know my starting value, but shucky darns, the 150th term is a mystery, so shall we math? Let's math. I know my first term, and then the difference, let's see, 5 to 16, 16 to 27. My difference is 11. So I could go through, plug what I know into this green formula. I would get the explicit formula of 11n minus 6. And that gives me permission to find the 150th term. If I plugged 150 in for n, 11 times 150, take away 6, I get 1,644. And now I have all the ingredients I need to find my sum. So there we go. Next up, they give us the explicit formula. Sweet. And then it says find S8. Well, that is the sum of the first 8 terms. Okay, so they told me how many terms, right? That's pretty sweet. Now, I don't know the first term or the 8th term, but couldn't I figure it out pretty easily, right? Plug in 1 here, plug in 8 here. They gave me the explicit formula. Is that not what it's for? So if I plugged in 1, plug in 8, that's what I get. Now I have my first and last term, go to our formula, and we are sailing along. Next one. Ooh, word problem. Oh no. I want to know what is the capacity of an auditorium. Capacity meaning total people that can fit in this auditorium. There are 30 rows of seats. Okay, so 30 rows. They just told me how many rows I'm adding together. There are 20 seats in the first row. Okay. They just gave me the very first term. Excellent. 24 in the second, 28 in the third, yada, yada, yada. So I took the information and sequenced it out, right? So now it's in a list. And I'm noticing, okay, the common difference is 4. So I'm going to go ahead and use this formula here to figure out, well, how many people would be in the 30th row? Because as long as I have the first and the 30th, then I have all the ingredients I need for this. Well, let's go ahead and do that. If I know my first term is 20 and the common difference is 4, and I plug that information to this green formula here, this is my explicit formula that I would result in. So my 30th term then would be 136. Well, now that I have the 30th term, I've got everything I need to plug it into my summation formula. and we would get 2,340 seats. Neat. All right, now I'm going to throw some brand new notation, which might not be brand new because some of you guys have taken some science classes that introduce this. Sigma sums. Yay. A lot of times you're going to see these problems not listed out in this format, right? Because that's kind of cumbersome. Instead, it'll be listed out like this, where they give you the explicit formula right here. And then it says, I want you to add the first term all the way through the whatever term, in this case, 20th term. If I want to find the first term, I just plug in 1 for here. If I want the 20th term, I'd plug in 20 for here. So I have the explicit formula. Where am I starting counting? Where am I ending counting? And then this sigma just says, hey, take all those values and add them together. Now, when we talk about our formula, oops, that's not the page I wanted. Right here, the big question with sigma notation is going to be, how do I find out how many terms I'm talking about? Well, to figure that out with sigma notation, you're going to take the top number minus the bottom number and then add 1. Make sure you add 1. The reason why we have to add 1 is because that term is actually included. Okay, so since we're counting that first term, I can't just do 20 minus 1 and call it 19 because there's not 19 terms, there's 20 terms. So we'll have to do top number minus bottom and then add 1 because we are including that original term that we're counting. Now, this sequence and summation formula can only be used if we're dealing with a linear function, meaning wherever I see the variable, in this case right here, I can't see any radicals, exponents, no funny business, right? Just some number times n. I can add or subtract whatever crap I want to at the end, doesn't matter, but I can't have any funny business on the variable itself. All right, so let's see an example. I want to know the sum of the first 70 terms of the formula 5n minus 3. So I'm going to follow this formula here. There are 70 terms total, right? 70 minus 1 plus 1, I get 70. I don't know the first term or the nth term, but I can find those, right? I can just plug in 1 and then plug in, let's see, what is the top number? 70. So if I plugged in 1, I'd get 5 times 1 minus 3, and then 5 times 70 minus 3. That's not too bad. So I can do both of those operations. So first term, last term, and there are 70 total terms. Well, those are all 3 ingredients that I need to plug into my summation formula. When I do that, this is what it'll look like. Number of terms over 2, first term plus the last term, in this case, the 70th term. Not too terrible, right? And this is very heavily calculator based. I'm not expecting you guys to know how to do 35 times, let's see, 349 without a calculator. That would just be very impolite on my part. All right, now let's see a different one. This one's slightly different because right here, you'll notice we're not starting at the first term. We're starting at the 5th term. But remember what we said way back. If you don't begin with the first term, then A1, whatever we call A1, is just whatever the first term you're dealing with is in that sequence. So in this case, when I plug in 5 for n, I'm just going to pretend that that is A1, right? So now if I want to figure out the number of terms, I'd have to do top minus bottom plus 1. So 75 minus 5, and then add 1 because I'm including that starting term. I would get 71 total terms. A sub 5 is 12 if I plug in 5 for n. A sub 75 is negative 268 if I plugged in 75 for n. If you don't believe me, go to your calculator. Now that I have these 3 ingredients, that's all the intel I need to use my series sum formula. So plug in what you know. Again, this is going to be on a calculator. No worries. We should get negative 9,088. All right, so that's it for this one. Let me know if you have any questions. Shoot me an email, send a comment on the Google Classroom, whatever. Good luck, have fun, be safe, roll tide.